Hey guys, glad you're here watching the help video for quiz 4.06. So lots of stuff to remember here. Remember, slope of parallel lines have to be the same. For perpendicular lines, you change the sign and flip it. This is your slope-intercept form. M is the slope. And then to find slope, if it's a graph, you can do rise over run. And if it's two ordered pairs, you can do the change in y over the change in x. All right. So the first problem says the coordinates of the vertices of triangle JKL are here. Now it doesn't give you a graph. I just chose to graph it because I'm very visual and I like to look at graphs. So I went ahead and drew a graph. And one of the reasons that helps me is because we're trying to decide if it's a right triangle. And if I want to figure out if it's a right triangle, what I'm going to do is I'm going to look over here and say, okay, what angle looks like a right angle? And the only one that has a possibility would be this angle. So I'm going to find the slope of those two lines. Now again, because I'm really visual, I would probably just do rise over run. So I would rise up 2, and I would run over 1, 2, 3, 4, 5. So the slope of this red line would be 2 over 5. And then I would do the same thing for the slope. I need to find the slope of this green line. So I'm going to go up 1, 2, 3, 4, 5, 6. And I'm going to run backwards 2. That's a negative 2. So my slope of this one would be 6 over negative 2. And for it to be a right angle, they have to be opposite reciprocals. Remember, perpendicular means you have to change the sign and flip it. So these are not perpendicular. Let's see. I don't know how to write that. That's perpendicular. These are not perpendicular. And that was the only hope that we had of a 90-degree angle. So this is not going to be a right triangle. All right. Let's try the next one. Here we have coordinates of a triangle. Okay, so the first thing we have to do is find the slope of JK. So this time I'm going to use the slope formula. Remember, that's the change in y over the change in x. All right, so if I'm doing J and K, I'm going to go ahead and label this one x1, y1, and this is x2, y2. And then I'd plug them in. So y2 minus y1 over x2 minus x1. And the slope there is negative 1/3. All right, then it wants me to find the slope of KL. So I'm going to do the same thing. I'm going to use K and L. Since K is already labeled as x2, y2, I'm going to go ahead and label this one as x1, y1. Doesn't matter which one's which. All right, and then I'm going to plug it into my slope formula. So I'm going to do y2 minus y1 over x2 minus x1. Two negatives make a positive, so on the top I'd have 6. And on the bottom, I would have 2, and that reduces to 3. So the slope of KL is 3. And then it wants the slope of JL. So we need to do it one more time. So J is labeled x1, y1. I'm going to go ahead and leave it like that. And then L, I'm going to make x2 and y2. And then I'm going to plug it in. So y2 minus y1 over x2 minus x1 would give me negative 7 over 1, which is just negative 7. And then it says triangle JKL either is or is not a right triangle. I need to figure out whether it is or is not. So I need to go back and see, are there any perpendicular slopes? Because remember, for it to be a right triangle, it has to have a 90-degree angle, which means that there has to be a set of perpendicular slopes. In perpendicular, you change the sign and flip it. So negative 1/3 and 3, those actually are perpendicular. So it is a right triangle because two of the slopes have a product of negative 1. This is another way, I haven't talked about this yet, but if you want to see if they're perpendicular, you can always multiply two slopes together. And if they equal negative 1, then you have verified or proven that they are opposite reciprocals. So that would be the answer there. Okay, the coordinates of the quadrilateral are given. It doesn't give you a graph though. So again, I just pulled out a piece of scratch graph paper and I plotted this because I'm really visual. It helps me to see. It's asking whether the quadrilateral is a rhombus. Well, I'm going to do some math, but just by looking at this picture, it doesn't look very good. It doesn't look like it's a rhombus. All right? So I'm going to go ahead and err towards the fact that it is not a rhombus. I'm going to cross out the ones that say it is. And then let's check. For it to be a rhombus, it's got to have some parallel sides. So let's see what all these answer options say. It is not a rhombus because the opposite sides are parallel, but the four sides do not have the same length. Well, they're opposite sides. Let's see if they're parallel or not. Let's go ahead and let's do this one. I'm going to do rise over run. So that's 2 over 5. So this blue slope right here is 2 over 5. And then I'm going to go to the opposite slope. And again, I'm going to do rise over run. And that's 3 over 5. So those opposite ones are not parallel. They're not the same. So we can't say that they are parallel. All right. The next one says the quadrilateral is not a rhombus because there is only one pair of opposite sides that are parallel. So I guess we need to check to see if the other pair of opposite sides are parallel. It's not looking good, but we'll check anyway. So rise over run. We rise up 4 and we run backwards 4. So 4 over -4, that ends up being just -1. And then let's check the other one. If we do rise over run, we rise up 5 and backwards 4. So those are not parallel either. So it doesn't have one pair of sides parallel. The quadrilateral is not a rhombus because none of the sides are parallel. You could do this same problem without graphing it, just by finding the slope of each of these. Like you would find the slope of AB, the slope of BC, the slope of CD, and the slope of AD. And you could use this same formula that we used back here to do it. I just happen to be visual, so I like to graph it. Okay, this one says we have the coordinates, and then we want to drag them into the correct place. So for this one, I'm not going to graph it. I'm going to just show you with the formula. So the first thing we need is the slope of JK. So I'm going to go up here, and I'm going to use my formula to figure it out. So y2 minus y1 over x2 minus x1 gives me -3 over 7. And then it wants the slope of LK. So since K is already labeled as x2, I'm going to make this one x1 and y1. And then I'm going to come over here and do it. So y2 minus y1 over x2 minus x1. And again, it doesn't matter which one you let be x1 and y1. So don't get hung up on that. 4 over 2 reduces to 2. So this slope is 2. Then it wants the slope of ML. So let's see. L is labeled as x1 and y1. I'm going to leave it as that. So M would be x2 and y2. So y2 minus y1 over x2 minus x1. This would give me 3 over -7. And that's the same thing, -3 over 7. It doesn't matter where the negative is, whether it's the top or the bottom. All right, and then we need to find the next slope. Let's see, what color haven't I used yet? Green. Let's do green. M and J. So M is labeled as x2, y2, so I'm going to let J be x1 and y1, which it looks like it already is. All right, so I'm doing M and J. So y2 minus y1 over x2 minus x1, which gives me a -4 over -2 which reduces to positive 2. Alright, so the quadrilateral either is or is not a parallelogram. Well, in this case, we have opposite sides parallel, so this one is a parallelogram because both pairs of opposite sides are parallel. Alright, and then the last one, we're given the coordinates of a quadrilateral. We're not given the graph. You don't have to graph it. Again, I just like to graph it. So when I graph it, my first gut reaction is that this is not a rectangle. Like if I look down here, this does not look like a 90-degree angle. This doesn't look like a 90-degree angle. It just doesn't quite look right. So I'm going to go ahead and cross out the ones that say is a rectangle. And then my other options are it has only 2 right angles, only 1 right angles, or no right angles. So in order to figure out if they're right angles, we need to check to see if they're perpendicular. So I'm going to find the slope of each. And since I already graphed it, I'm going to do rise over run. So for this one, I rise up 4 and backwards 3. So for the green line, my slope is 4 over negative 3. It doesn't matter where the negative goes though. All right. Then I'm going to find the slope of this one. I know I kind of went off my graph, but I start at 9, go up 10, 11, 12. So I go up 3, and then I run backwards 1, 2, 3, 4. So the slope here would be rise 3, backwards 4. Let me keep finding the rest of the slopes. For this one, if I do rise over run, I rise from 3 to 12, so that would be 9 units. And then I go over from negative 6 to positive 3, so that's also 9 units. So the slope here is 9 over 9, which ends up being 1. And then for the last one, we have to rise up and over. So I go from negative 1 to 9, so I rise up 10 units, and then I run over, 10 units. Is that 10? Yeah. So that one's also 1. All right, so now let's compare. Right here, I would need the slope of the red and the slope of the green line to be opposite reciprocals for that to be a 90-degree angle. And red and green are not opposite reciprocals, so that one's not a 90-degree angle. All right, over here, I would need the slope of the red and the blue line to be opposite reciprocals. Red and blue, not opposite reciprocals, that is not 90 degrees. Right here, I would need the slope of the blue and the purple to be opposite reciprocals. Blue and purple are not opposite reciprocals, that's not 90 degrees. And down here, I would need purple and green to be opposite reciprocals. Again, that's not 90 degrees. So it has no right angles. None of those are going to be perpendicular. All right, good luck on your quiz.